Hi folks, you're welcome once again to another fascinating mathematical video. As usual, we shall be considering past questions from the integral calculus. As such, we shall not be considering detailed concepts, explanation of concepts. Rather, we shall assume familiarity with these concepts. All right. You well know that it is not proper to look into deep concepts when considering solving past questions from various examination board. But I will throw more light into the solution so you can grapple with it. However, if you have no foundation on the calculus, I'll present before you two options. One of the options is you can employ me as a personal tutor. And in this class, I will explain in detail to you from the very foundation what you need to grapple with the calculus. All right, and not just calculus, with the whole of mathematics. Uh, I'm a mathematician. I study mathematics and I'm very prolific when it comes to the area of mathematics. All right, so um, you can consider me as your personal tutor, and in this class we shall hold together. In fact, it will be an interesting one. It's a time whereby you can talk to me, you can ask me questions if you're not clear about any concept, and I will also immediately reply you. All right. Unlike this particular one, you can't talk to me. I'm the only one that can communicate with you directly because I'm the one providing the video. But in the one-to-one class, you have the right to discuss with me. You tell me what where you are not clear, and I will try my best to make it clear. All right. Then also the second option is that you can click the link that is provided and to take you straight up to my Telegram group where you will get a step-by-step breakdown of the concepts. All right. So whichever is best to you, you choose. This is all left to you. Now let us consider the solution of this particular integrals. We are required to evaluate these simple integrals. I call it simple because some integrals are more involved when compared to this. So let's look at the solution of these integrals. The first one over here, solution. We have to evaluate the integral of 1 over, you see me calling it 1 over. I don't say ds over because ds here is not taken to be a fraction, but rather we consider it as an infinitesimal quantity. So I can say 1 over 1 plus the square root of x plus 1. All right. Now it is a well-known thing that this expression can be written as the integral of 1 over 1 plus square root of x plus 1. Then I can write dx du du. All right. Where this expression you are seeing here is the result for this. All right. Now you are familiar with this expression 2x. Now we call this 2 here, we call it the coefficient of x. All right. So in similar manner, dx du, while this is a derivative, this is called a differential. All right. Um, there's a clear difference between derivative and a differential. Please don't confuse the notion of a derivative with differential. Now, in fact, we call this a differential coefficient because since 2 here is a differential of x, also this derivative is a coefficient of u. All right, 2 is a coefficient of x here. Then this derivative is a coefficient of this differential du. Hence, we call this a differential coefficient. So take note of that. It is wrong to assume that du cancel out du. No, that is not the case. This dx is a result of multiplying this derivative with a differential called du, and that will give us the differential dx. All right. So that aside, let's go over to the solution of this problem. All these are trivial cases. Now, this derivative here suggests to us that x is a function of u. That is, there exists a certain relationship between x and u. Now, the relationship can be gotten in different way by different integrators. But to make it extremely easy, we make a substitution that will simplify the integrand considerably. Now, in such a case, we shall say let u be equal to 1 plus square root of x plus 1. All right. Some people will prefer u squared equals x plus 1. That is still okay. But if you practice that, you see that it will be longer than this particular one we're considering now. Now, isolating x in this case implies we have um, we have square root of x plus 1 equals u minus 1, all right? From whence we have x equals to u minus 1 all squared minus 1. You see that? So from this relation, we can get our dx du over here. Can you see that? In that case, differentiating with respect to u, we have our dx by du to be equal to 2u minus 1, and this is the answer. So what we do now, we put this data into the integrand. So we can say, therefore, the integral of 1 over 1 plus the square root of x plus 1 is equal to the integral of 1 over, now we said initially that let u be 1 plus square root of x plus 1. So in that connection, in place of 1 plus square root of x plus 1, we shall put u, all right, times. Now we have already obtained our dx du, which is over here, to be 2 brackets u minus 1 with respect to u, all right, from this expression. Hope you can see that. So in that case, 2 is a constant, it can be factored out, so we have 2 integral, we are left with u minus 1 over u du, all right. Then this will give rise to writing 2 the integral. Now u divides into u, we have 1, all right, minus u divides into 1, we have the result as 1 over u du, all right. Then this we integrate each term. When we integrate each term, integrating 1, we have u as a result, all right. Integrating 1 over u, we have log to base e of u as a result, plus c. Now, it is not proper to leave the result like this because we made some substitution from the beginning. We said let u be the square root, let u be 1 plus the square root of s plus 1. So in that case, we have to put back what is u. Now, in this case, u is 1 plus the square root of x plus 1, all right? So we're done with that. A log to base e. In place of u, once again, we put out the same expression, 1 plus the square root of x plus 1. And this become the answer, then plus an arbitrary constant. Please always put an arbitrary constant of integration. And this is the final result of this particular integral over here. Can you see that? So we're done with this particular problem. So over to the next, number 2. In number 2, we are to evaluate the integral of 1 over 1 plus exponential x. So let's go there. Integral of 1 over 1 plus exponential x, and this can be written as 1 over 1 plus exponential x. Then we can be recast as dx by du, all right. Now pay attention carefully. This dx du suggests that there is a relationship between x and u, all right, and we are the one to choose the relationship. As I said, different integrators will choose the relationship in different ways that seem good to them, but for me, I will say let u be 1 plus exponential x, all right, from whence we have our exponential x to be u minus 1, all right. Now on differentiating with respect to u, we have this as exponential x du by dx, because we are not taking s as a function of u, so that makes exponential s a function of a function, all right. So we have this equal to, now differentiating u, we have 1, all right. Then isolating du dx, we have du dx equal to 1 over exponential of x. But of course, exponential of x has been found to be this here. Hope you have seen that. So in that case, this is further equal to 1 over u minus 1. And that is the result. So we put this data into our integrand. So let me take more page. The page is exhausted already. All right. So putting these results we've considered into the integrand, we can say therefore the integral of 1 over 1 plus exponential x is equal to writing 1 over, now in place of 1 plus exponential s, we put u. That was our agreement initially. Look at it over here. Can you see that? We agree that u should be that expression. Now the x du has been gotten as 1 over u minus 1. So in the place of the x du, I can put 1 over u minus 1, all right? So we have du, all right? So this integral then simplifies to writing integral of 1 over u multiplied by u minus 1 du. Now this fraction is a proper rational function. So, and it can be split into partial fraction, or partial fraction is a concept that needs to be discussed. But as I said, we shall not be considering detailed explanation of concepts. Rather, we shall assume familiarity with the concept because of time. I don't want these videos to be too lengthy. Otherwise, it will make it to be monotonous, and you will become discouraged if it's too long. So because of that reason, I don't want to explain different, and it's not even proper to explain an entire topic or topic in just one video. It's not proper. All right. So if you want that detailed explanation, as I said to you earlier on, you can employ me as your private tutor. In that class, I will be taking you one-on-one, and we shall go in depth. You can ask me questions of any sort you want to ask me. I'm ready to explain to you, to bring to your understanding everything that is being talked about. All right. If I don't forget, your success is my ultimate goal. That is your success, my ultimate goal. I'm a motivated tutor. I like motivating students. I like putting inspiration on them. Mathematics is very simple. It's not difficult at all. Then second option, as I said, you can visit my Telegram group. Here you get a step-by-step breakdown of everything that is talked about. All right. So let's assume the idea of a partial fraction. In partial fraction, we want to split this into partial fractions. Now, consider the denominators. You see that they are linear denominators. Because they are linear, we have the numerator to be a zero numerator, that is a constant. So we can say let a be the constant of the first, we have over u here, plus then b will be the constant of the second, we have u minus 1 over here, all right? Then with respect to u. So where a and b are to be determined. Now to determine a, this a you are seeing over here, what we do, we cover this expression u, this expression you are seeing here, u, in this part, all right? When we cover this u, what we do, we substitute 0 in the other s here, all right? If we cover u, what will be left? We'll be left with 1 over u minus 1. So we substitute 0 in that leftover expression. So on putting 0 here, we'll be having 1 over 0 minus 1. That will give us minus 1. So that means my a value is minus 1, all right? In that case, I have it as the integral. In place of a, I can now put minus 1 over u plus. Then the same thing we do with b. Now, in case of b, we cover up u minus 1 and substitute 1 in the place s here. The s here in this case is 1 over u, all right? We cover up u minus 1, which is here, and substitute 1 s here, which is 1 over 1, and that will give us 1. So my b value is positive 1 over u minus 1. So this integral you are seeing here, this current integral, is a familiar one and is very easy. So the result of this integral will be equals to, on integrating this first term, we have minus log to the base e of u plus the same thing with the second, we have log to the base e of u minus 1, all right? Plus c. Or this can also be rearranged as log to the base e of u minus 1 or minus log to the base e of u, all right? Plus c. And this now can be written as log to the base e of u minus 1 over u. All right, we can leave it like this, but we can't leave it in terms of u. We have to substitute back our expression. Don't forget, initially we say let u be 1 plus exponential x. So in this case, we shall be having result as log to base e of exponential x over exponential x plus 1. Hope you don't have any issue with this. When you put exponential x plus 1 here, minus 1, you would reduce to exponential x, all right? And this become the answer. So please take your time, go through it once and twice and thrice if possible to get full grasp of everything that I've talked about, all right? So we go over to the third question, the third. In the third, where we have a third is repeated. The third and fourth are the same thing. So we take one. Sorry for that. We'll take one. Let's take this one. Then number 5, I will leave it to you as an exercise. All right. You will try number 5. That will be your exercise. So let's take number 3 and work on it. Number 3, we want to evaluate the integral of 1 over the square root of x plus the cube root of x. This is the result. As usual, this can be written as the integral of 1 over the square root of x plus the cube root of x dx du, all right? That means we have to seek for a relationship between x and u. In this case, we can say let s be u to the power of 6. Why did I say so? Observe that root s is equal to writing s to the power 1 over 2, all right? Then also, the cube root of x can be written as s to the power 1 over 3. And 6 is a multiple of 2 and 3, all right? So we can say let s equals to u to the power of 6. Now, in this case, the x du becomes 6 u to the power of 5. So substituting this data into our integrand, we have it as follows. Therefore, the integral of 1 over the square root of x plus the cube root of x is equal to writing the integrand of 1 over, we have square root of 6 to the power, u to the power of 6 rather, plus the cube root of u to the power of 6, all right? That was our agreement. Then dx du over here, we've obtained it to be what? 6u to the power of 5. Then we have du. So we have to evaluate this current integrand. So this now reduced to 1 over u to the power of 3 plus u squared, all right? Then we have 6 can come out because it's a constant. Then we are left with u to the power of 5 du, all right? Now this can also be written as 6 integral. Now we can write this as u to the power of 5 over, what is common here? You have u squared, right? We have u plus 1 du. Then on division, we have it as 6 integral of u to the power of 3 over u plus 1 du. All right? Now, this can be written as 6 integral. Then we can take this as u to the power of 3 plus 1 minus 1 over u plus 1, then du. All right? So we have that as a result. Then this divided 10 by 10, we have this as u to the power of 3 plus 1 over u plus 1 minus 1 over u plus 1, all right? Du. Hope you can see that. Page once again is exhausted, so I will take more page again. All right? Then the first here can be written as, now this one you see here, we can factorize it, and the factor form of that is u plus 1 multiplied by u plus 1 all squared minus 3u. All right, over u plus 1. All right, then we have minus 1 over u plus 1, then du. Can you see that? If you want to verify, you can expand this. You are seeing here, you will discover that it will give, if you expand this, it will give you exactly this. Sorry, it will give you exactly this. All right, you can do the expansion. You see, you get the same result. I don't want to go into process of deriving it because of I don't want the video to be long. Then we have 6 integral. This can cancel out with this on division. So we have u plus 1 all squared minus 3u remaining. then minus 1 over u plus 1 du. All right. Then integrating term by term now yields 6 bracket. This will give us u plus 1 to the power 3 over 3 minus this will give us 3u squared over 2. All right. Why this will give us log to the base e of u plus 1. All right. Plus c. And this is the answer. So we can expand through. When we expand through, we have 2u plus 1 to the power 3 minus 3 times 3. That will give us 9. All right. That will give us 9 u squared minus log to the base e of u plus 1 and then plus c. This is c. This is not 6. Take note of that. This is c. All right. An arbitrary constant of integration. Now, this is the result, but we have to replace our u in terms of x. Now, we said initially let x be u to the power of 6. Now, if x is u to the power of 6, it means that u is equal to the 6th root of x. All right. So in the place of u, we shall put the 6th root of x there. So we come over here and do so. We now have this as 2. In place of u here, I'll put the 6th root of x. All right. Then plus 1 power of 3 minus the same thing follows. Then we have the 6th root of x. Let me remove this from here. The 6th root of x. All right. Okay. The minus log to base e, the same thing we have apply here. The 6th root of x plus 1. Then plus c. Please take note, there will be 6 here also. The 6 will also expand this. Here will become 6. Here will become 6. This is the correct thing. Then plus c. So this is the solution to this last one. Very, very easy. It's not difficult at all. You take your time, go through it once, twice, thrice, if possible, to get full grasp of what I've taught you. Or if it's not clear, you can reach to me, you can indicate. All right. So have a good day. We stop the video here. The last one, number 5, I said it will be an exercise. You try it, attempt it. It's not difficult. It's very easy. Make an attempt to solve it. It involves a trigonometric function, but the trick is very simple. So thank you very much for paying attention. I really owe you a regard.